Hi, this is Thomas from Apex Game Tools. In this video we'll be talking about vector fields. In Apex Steer, instead of using steer for path to move units, instead units and groups will be moving using vector fields. That means instead of each unit having a path on their own, they will just have one path as a group. That path will be converted into a vector field and the units will move along this. We'll see how these vector fields look in just a second. Now on each unit we will have this steer for vector field component, which is similar to steer for path. It simply follows a vector field instead of following a path. It also has similar properties to steer for path. It has one additional one down here called arrival radius margin, which controls how close the units need to be to their final destination in order for them to see themselves as having arrived. But this option will likely change in an upcoming release, so I'm not going to go more into that. Now, for the majority of the settings for vector fields, these are found on the game world, specifically on the vector field manager component, where you can select what type of vector field you want to use and set the settings for these individual types. And we'll be looking at these types of vector fields, and I'll be explaining the strengths and the weaknesses of each. So at the launch of Apex Steer we will have these four: the full grid, the progressive, CrossGrid and funnel vector field. Now the preferred option is the funnel field, so we'll start by looking at that. And before we get into the options, let's just see how it looks. So the funnel field creates a vector field from the start to the destination in a funnel around the units. So when I move my units down here, it will generate a vector field that surrounds the unit moving towards the target. Now for the options, the three first options are shared among all the vector fields. Built-in containment controls if the vector field is generated in a way so that it will point units away from areas where they should not be, such as edges of the grid, holes and such, so that we don't have units that are moving to places they should not move. So this is a recommended option. The next one is the update interval. For this particular field and for one of the others as well, this is actually not used for the actual updating of the vector field because it isn't updated. The funnel vector field is created once when the path is received, and it will not change unless the path changes. Then we have an obstacle strength factor. This controls how far away from an obstacle that the vector field will actually point units away. So in other words, it controls how close to obstacles units will generally move. And finally we have the funnel width, which controls how wide it is, the funnel. In this case, that is seen from the center of the group and to the edges. So as we saw before, it had a width of 4, which was rather slim. If we double that and we start it again, we'll see that it will double its width and have a much wider field. Now for the most part, the width is, you only need a width that covers the group. But as groups can sometimes be spread, I mean units don't have to be all grouped up like this when they move. You can have groups selected that are slightly spread out as well, and in that case if you have a wider field, they will sooner get onto the vector field and start moving along that. So let's have a look at the next option. The next is the full grid. Full grid vector field simply generates a field on the entire map. So we do the same, and as you can see we have now a vector field covering the whole map. And as you can probably also imagine, this is not exactly the best performing option, because it wastes a lot of time generating a field where most of the field is actually not needed. We only needed to move from up here to down here, so all the space over here and up here is just not needed. We're not going to use it, so it's basically a waste of time. So you would normally prefer the funnel field over this, but there might be some situations if you have very small maps, or if you have a group that you want to generate just one vector field for and have them move along that continuously, you can do that. As for the different properties, it just has the three that we mentioned before. It has none of its own. Then we have the progressive field. The progressive field, well, instead of creating a grid from start to finish, just create a field around the units as they move. So it will just create a fixed field around the units. I'll just show you. So moving down here, as you can see, the field doesn't cover the entire path. It just covers an area around the units moving forward. Now this can have the advantage of if you have large maps and you have groups of units that you expect to move long distances, they will only generate this small vector field all the way. It will do this in a load balanced way, so it will generate it every set value that we'll get back to in a second, so it won't generate the full field from start to finish. So performance-wise, for very large maps and long distances, this may be a preferred option. It does, however, move a little bit differently, since it does not know of the exact destination when it starts moving. It only knows about its immediate surroundings. The movement pattern of the units using this type of vector field will be slightly different. So this type of field has quite a few options in addition to the three we just mentioned. It has a growth factor for the group. This has to do with how you expect the group to grow. If the group is widely spread out, or you expect it to spread out along its route to the destination, then you should set this to a higher value. This basically controls how the vector field will grow itself as units move. Units, obviously, the vector field needs to encapsulate all the units that are moving in it. The next one has to do with how the size of the vector field when it starts out. So the padding, the start padding around the units, it is comparable to what we had on the funnel field, the width of the funnel field. In this case, it will just basically be the distance from the center and to each of the sides around the units. So it's a padding around the units, basically the starting size of the field. Then there is an increase amount. This is the amount by which the field will increase when it needs to resize itself. Sometimes the field will have to resize itself to be able to see its next node on the path. So it will grow larger, and then it will shrink back again to its previous size. And this controls by how much it increases itself each time until it actually reaches a size that allows it to move to the next node. And then we have this max, which controls how big it can get total. So in this case, we will not allow it to get any bigger than 30 on each side. It should only be allowed to grow 30 meters on each side of the units. Larger than that, and it will simply not grow any further. And then lastly, we have this setting to control when it actually updates itself. As I said, it is a load balanced update. It will update itself in this case when the units have moved 2 meters from their previous center of gravity. Obviously, if you set this to a lower value, it will update more frequently. If you set it to higher, it will update less frequently. So that brings us to the last option, the CrossGrid vector field. And I'm actually not going to go into details with that. The CrossGrid vector field has to do with portaling, being able to cross multiple grids using connector portals. But as we actually have we don't have support for portaling, or at least not proper support for portaling in the initial release, I'm not going to go into that. We will be adding proper support for portaling in a later update. So that's basically it. That's all there is to say about vector fields at this point. Hope that made sense. See you in the next video.